Hi, and welcome to this week's episode on programming with Fixitgearware Security. Last week, we discussed about how to write programs using various approaches such as top-down analysis, modular programming, structured code, and so many other interesting concepts in C programming. So if you're yet to see the video on this topic, kindly click the link below in the description. On this week's episode, which marks it the fourth since we started the series, we are going to discuss the concept of writing algorithms, the numerous ways of stating algorithms, and creating of structural codes using step forms in C programming. So without wasting much of your time, let's move on to today's programming concept. The concept of writing algorithms and creating structural codes involves using step forms. So what is algorithm? By definition, algorithms are part of the computer program that serves as an effective measure of procedures in solving problems using finite numbers of steps. Effective in the concept of algorithm implies that answers are found, and finite numbers of steps means the steps before the solutions are attained can be predictable or determined. The second point is there are numerous ways of stating algorithms, and they are 1. Step form, 2. Pseudocode, 3. Flowchart, 4. Nazi-Schneiderman. For the step form, this procedure involves stating the problems in written statements, with each statement solving a part of the problem, and together all part of the solution make up the statement. For pseudocode, it uses restricted vocabulary to properly define actions of solving the problem. It is also considered as human language. For flowchart, flowchart presents the algorithm in a graphical manner or orientation, and this graphical manner and orientation uses the symbol and language to represent sequence, decisions, and repetition actions. For the Nazi-Schneiderman, it also involves the graphical representation of algorithms, problems, using the same concept as flowchart. So I suggest you research and read more about these numerous ways of stating algorithms, or at best, be at alert when we publish our paid programming courses, as we will be discussing this concept in depth in these courses when we publish them. Another tip also in stating algorithmic problems is that for you to understand algorithmic questions, you must first understand the basic concepts of maths, as this is very important in solving programming language. So today, we'll be solving two algorithms, teaching you how to spot their concepts and solving them easily to write readable and structural codes using step forms. So moving on to solving these simple programs using step form, let's deal with two examples and show you how to dissect and solve this problem. The first problem, write an algorithm for the sum of any two numbers. And for the second problem, construct an algorithmic program that determines the remainder between two numbers using the division operation, where both dividend and divisor are both integers. Integers are data types. If you know about variable names and data types in programming, you will fully understand the terminologies in these two examples or various sentences in a given programming problem. And if you don't, do not worry, we'll be discussing these various data types and variable names in C programming in next week's episode. So without wasting much time, let's move on to solving these two examples as given. For example number 1, we're asked to write an algorithm for the sum of any two numbers. To write this program, we can solve this problem in two different ways. And these two different ways will be describing it in this example. So let's write solution using step form. So on the back end of our software program or viewing the source code of a program, there are a series of steps that the program will take before it successfully executes the instruction the program is designed to perform. So the first solution, for example, number 1, before the program has to execute, the program has to start first. So we say start. Now, highlighting the major key point of the question, it says write an algorithm for the sum of two numbers. So this is the sum of two numbers. So after starting the program, the next thing we want to do, we want to print the instruction on the terminal or the front end of the program requesting the user's input. So we can say enter two numbers. So you might be asking why this instruction. We were asked the sum of any two numbers. So we can say enter two numbers. So this is the prompt request asking the user of the application to enter the number. Once the user entered the number, what next is the program is supposed to do? The program is supposed to receive the input. So we'll instruct the program to receive the input. Now for step 4, the sum of these two numbers should point to a variable or should have an outcome, right? So let's call this variable to be O1. We use the O1 to be output, and O1 points to the first integer N1, and it says sum of any two numbers plus N2. Now for step 5, after we have received this input from the user and the program has conducted the computational outcome of these two numbers, we should then proceed to print the result. Then we instruct the program, if two numbers have been given, print O1. And after this has been executed, what's the next step for the program? Is to either stop or end. And that's it. That's the simple way to solve this program. First, looking at the algorithmic question that was given, we can see that the program first has to start, receive the two numbers that it has to sum from the users, and this will go into the program as an input, and the outcome of these summations will now be printed. And after that has been successfully executed, the program ends. Now, the problem with this first approach is that, let's say you're writing a complex program or a complex code. Receiving two inputs together, it's not a good practice in software programming. And you might ask why. It's because, let's say the complex program has some issues or there are some errors in the program, resulting it to fail or the program to crash. It will be very difficult to detect or trace back what part of the program is actually having these issues. So this is an easy method, but in the concept of programming, it's a bad approach. So to simplify this whole thing, which makes us understand what the user is doing, we have to now write the second approach, second solution. We can now say the program should first start. After the program has started, we can now say enter the first number, enter the first number. Then we instruct the program to receive the input N1 from the user. Then after this number has been entered, we now instruct the program to launch on the interface, enter the second number, and we tell the program to receive the input N2. Now, after this program has received the input of the second number, then it should do the computational sum of N1 and N2 to point towards the output of the summation of these two numbers, which is O, we call it O1, and the summation of N1 plus N2 gives us the output. Then we said the program should print output. Then after the program has successfully printed the output, we instruct the program to either stop or end. Now, if we compare these two programs, the first solution and the second solution, which is a good practice in writing the code? Of course, the second approach is, and it's a good concept because right now, when you supply this code or this source code to a novice or someone else who is advised to inspect this code, the person is going to fall in love with the second approach more than the first approach. Because why? The top-down approach is properly outlined and the instruction of the execution of the code is understandable. So when I look at the second approach, I understand that, okay, the first thing the program has to do is the program has to start. And this program involves computing two numbers. And what does the program do after starting? It asks me for the first number. And once I give the first number, it accepts it, which is the input N1. And then says, okay, I have accepted this first number. Please give me the second number, which is what? N2. It now says, okay, I have also received the second number. So now I have to do the computation of these two numbers that you have given me and pass it to the output, which is what? N1 plus N2. Then if this summation is successful, then I print the output. And after printing this output, I stop the program. So in the case right now, let's say this program crashes using the second approach. You can now detect what part of the program is having the issue. Maybe let's say after you enter the first number, the program doesn't request the second number. I can now say, okay, this program has an issue. I have to check from step 4 down to step 5 to identify why step 4 and step 5 is not properly executing. So this is very, very, very interesting. And this is a very, very good way to be a good programmer or writing cybersecurity tools. You don't just write code, but you also make them readable and also adopt the logic of good programming practices. So that's it for this example number 1. If you have difficulties on understanding this concept, please refer to the video and look at the various steps we have taken. Now, moving on to example number 2, we were asked to construct an algorithmic program that determines the remainder between two numbers using the division approach or division operation, where both dividend and divisor are both integers. So let's now dissect the keyword here. Construct an algorithmic program, okay, that determines the remainder. Okay, so this is the first keyword here, the remainder between two numbers. Okay, using the division operation, where both the dividend and the divisor are both integers. So what they are trying to tell us in this question is that we have to divide between two numbers, and these two numbers are integer data type or numerical values. And if you understand the concept of maths, when you divide two numbers, you will obtain two values. The first is going to be the quotient, and the second is going to be the remainder. So with this simple explanation, we have a good understanding of what this example number 2 is talking about. So let's solve this problem by first saying step 1, we have to start the program. Number 2, or step 2, we have to enter the dividend or first number, and the computer received this input. So let's call this dividend. Let's call it D1. Then the next thing we have to instruct the program is what? To accept the second number, which is enter the divisor or second number. And let's call it D2 since it's the divisor, right? Then after dividing these two numbers, it should point to the outcome, which is the quotient, right? So we call it 6. Let's call the quotient to be what? Q bracket 1. And the outcome of the quotient is D1 over D2. Then referencing back to the explanation we described, we said when you divide two numbers in a mathematical question, there will be two outcomes. One is the quotient and the other is the remainder. So after we have gotten this quotient, right, how do we determine the remainder value of this problem? So determining the remainder value, we can say R, which is the remainder one, points to D1 minus Q1 multiplied by D2. Then the remainder is what we want to print. Then we'll say print R1, and we can also say print Q1 if we actually want to know what's the quotient. And we can now say end or stop. Now, going back to the question again, we were asked the remainder between two numbers. So we're asked to print only the remainders. But in step 9, we introduced the quotient in case if we decided we want to make the program more friendly to tell us, okay, this is what the quotient value is and this is what the remainder is. But sticking to the question, if we do not want to print the quotient, we just want to stick to the question, then step 9 does not apply. Let's call this X cancel. So we won't print this outcome. But if we want to print both the quotient and the remainder, then we have to include step 9 in our program. But sticking to the question, we were asked the remainder between two numbers, which implies that what the program should print out is the remainder and ignore the quotient. And also the division between these two numbers. So moving back to the problem, you can understand that what the program should do is to divide two numbers, one being the dividend and the other being the divisor, which is divided by the division operator or division operation. And both dividend and divisor are both integers, means they are numbers or numerical values. And these numerical values, we both know in mathematical solutions, would have a quotient and a remainder. So the first thing we did here is that we started the program first, and we received the first number, which is the dividend, the number to be divided, and the computer runs the input as D1. Then in step 4, the computer program asks to add the divisor, and it runs the input as D2. Then the division between these two numbers gave us a quotient value, which is the Q1, and a remainder, which is R1. Now you might be confused why this is the remainder. Do not worry, we'll be explaining this in a jiffy, and this is where the application of maths comes in. Then after this value has been computed, we ask the program to print what the remainder of this value is. And after printing, if we are instructed to print the quotient, we told the program to also print the quotient. But in this problem, we're not asked to. We just included this to explain further if you want to make your program to give more information about the data supplied. Then after this has been done, we ask the program to end. So let's explain the step 9 of this program. Going back to the slide. In step 9, for us to get the remainder, the program exhibited a few steps. For step 1, example 2, we have a computational mathematical approach of N1, which is in this case D1, and D1, which is in this case D2. N1 being the dividend and D1 being the divisor. And the output is Q1, which is the quotient value. And if we apply cross multiplication approach and introducing a constant 1 in step 1 to the equation, we have the outcome of step 2. Now, if you have done addition and subtraction on both ends of an equation, then further doing mathematical subtraction in step 2 will give the outcome of step 3, which is N1 in this case, which is D1, the dividend, minus Q1, which is the quotient value we obtained, multiplied by D1, in this case, the divisor, and in the equation we just solved is D2. And both of them will give us 0. And if that is equal to 0, remember that that's the remainder, and we say the remainder, which is R1, can be equal to 0. If 0 is the outcome of this computational value of step 3, also known as the remainder, then the equation in step 3 is definitely equal to the equation of step 4, which is R1 points to N1, which is known as D1 in our program code we wrote, minus Q1 multiplied by D1, which is also D2 in the programming code we have written. So if the equation in step 4 gives us this, that means printing the value of R1 by the program will point to this computational value, which gives us this equation here, number 9. And after the program has executed this computational value, it then prints R1. Remember again, we're not asked to print Q1. We just included this should in case you on your own private time, you want to write a program and you decide you want to add more information of what the program's computational output is to user, then you can now include print Q1. Or if the problem you were given was asked to not just print only the remainder, but also the quotient value, then you can now also include step 9. Then after the program has successfully printed both outcomes, then the program ends or exits. So I hope with this explanation, you understand or you have understood the concept of writing, programming, or algorithmic problems using step forms. And last week we discussed a lot of concept, and if you look at this program as well, you can see that we applied the top-down approach, the modular approach, and the structural code approach. So this is why it is good to understand these various concepts, because when you start writing code, the mechanism or the concept start flowing because you now know what you're doing. Let's say you're comparing two variables, you're receiving an input, using conditional statements, iterations, comparing of values, switching between numbers and values like the case switch. This approach is very, very good. Once you understand this, you can even write not just malwares for training purposes, you can also write botnets, because at the end of the day, you're giving the code a series of instructions, which includes processes and executing patterns based on the concept which the program was written. So that is it for this week's episode. Do not forget to give us a like by clicking the thumbs up button, subscribe by tapping the subscribe button, and turn on notification bell to be the first to get notified when we post another episode on coding with Fixitgearware Security. Thanks for watching, and see you next week on another episode on coding with Fixitgearware Security. Bye for now.